Ladies and gentlemen, welcome to my presentation. For those who don't know me, my name is Daniel Hans-Peter, and today I'm going to talk about the application I've written for my thesis, which is an application for mobile devices and especially for Android devices, which aggregates different data related to skiing and provides also a tool for risk factor calculation. Today we'll have a brief introduction to the current situation about skiing and what motivated me to develop this project. Secondly, you will see an overview of the development process and the technique I used. At next point, the challenges I faced and the solutions and decisions I took. At fourth point, the feature, a list of the features implemented with a short description of each one. And at next point, the collected feedback about the usability of the software. And at the last point, conclusions of the thesis with some drawbacks for further improvements. Let's now start with the introduction part. The current situation of skiing is problematic. If users want to plan their trips, they have to search through several websites. There do not exist any central accessing point for that data, and most of times information of slopes is also incomplete. So a well-planned trip cannot be easily done. There is also a problem for those users who like to go off-track skiing. There do not exist any application or any mobile device which allows to calculate involved risks. And for those four major reasons, I wanted to create a software which aggregates skiing related data, which is a tool for risk factor calculation and which relies on up-to-date information to never lose overview of current situation. If we put together these three main reasons, we come to the purpose of the software, which is to make skiing and snowboarding more safe and trips more easily to plan through interactivity. Now we reach point 2, development process. For developing my software, I used a customized extreme programming technique learned at my previous internship but also on university. I said customized because I didn't use pair programming. I was alone at development and I didn't use test-driven development. So I first written my code, written my features, and then black box tested them. As you all know, during XP there is no real analysis, design, implementation phase, but they continuously change due that requirements continuously change during iterations. But if you look at them on a general view, during analysis I collected requirements by my friends. I asked them what they could need or what would be useful while skiing. Then I started collecting the theoretical parts behind the application. So I informed myself about risk factor calculation and about mathematical methods to calculate cardinalities and so on. Next thing I had to do was to focus on the retrieval of data to select sources which I want my software to rely on. During analysis phase, I selected the structure and architecture of the software. You can see here a general view of the architecture, the user which interacts only with the device, and the application which is installed on the device relies on three background components: the condition component, localization component, and media component, each one having one specific task. During implementation phase, I wanted to estimate and evaluate myself, and so I used, as usual during extreme programming, the product backlog in combination with PROM provided me by the university in order to have a more precise and more detailed estimate evaluation. At last step during implementation, I had to do some code optimization due to the fact that working mobile devices means to work with restricted performance. But let's now see challenges I faced during my development. The first one was to introduce myself into a new topic, which is risk factor calculation. And I want now to introduce you to that topic. There exist various risk factor calculation tools, for example, methods, the NIVO test, the red-green light technique, and the most common known, the Werner-Mantel reduction method. As the name says, this method tries to reduce something to an acceptance level. And if we look at the formula, it becomes clear that we try to reduce a danger level, and we calculate that level by taking 2 to the power of risk level. Risk level is a value which is took from the avalanche bulletin of each region we are trying to go skiing. For instance, here a picture of the risk level in February for South Tyrol, which was 3. So 2 to the power of 3 might be 8. And this level we try to reduce it by 3 reducing factors. And these 3 reducing factors are: first, the slope angle. The steeper the slope, the higher the probability of triggering, and so the less the reducing factor. The reducing factor 2, the slope aspect. Slopes located on the southern side of a mountain have a less probability of triggering because they're affected by the so-called melting freezing effect. You may ask, what is it? Well, being located on the southern side means that the slope is the sun shines a lot on that side, and so the snow melts. The snow melts, but when a cloud appears or by night, the temperature is that low that the snow freezes immediately again and makes the snowpack more compact, and so there is less probability of triggering of fresh snow. And risk factor 3 is just a probability factor. It's about how many people are skiing or snowboarding on the same place at the same time, and just meaning that having more people means higher probability to trigger. Once we have that 3 reducing factors and we put it into a formula, Werner-Mantel states 3 possible results. If it's less than 1, then it's safe to go. If it's equal to 1, then we have an uncertain situation. And if it's greater than 1, then it's surely unsafe to go. But let's see an example in practice. If we take the level of the picture on the slide before, we have 2 to the power of 3, which is 8. Let's say that the steepest slope we are going to face is about 38 degrees. So reducing factor of 1 is 2. And let's also state that the slope is located in the southern section of the mountain. So reducing factor 2 is about 3. The last thing to bring into our example is, for instance, that we are 2 participants, but let's make a particular case. Let's say that we have less than 10 meters between us, so reducing factor 3 is only 2 and not 3. Let's put the values into our formula. So 2 to the power of 3, as said, is 8, divided by the 3 reducing factors. 2 times 3 times 2 is 12, and we have as a result 0.67. And this means we are safe to go. The next challenge I faced was about altitude. To calculate the angle of the slope, I need the difference in the altitude, but the Android GPS provides only an imprecise value. Precision of about 50 meters is too big for something which people might rely on, and so I had to focus and search for an alternative solution, and I found a web service which provides altitude based on latitude and longitude. And so, as shown you before, the localization component tries to merge that data and combines that data to provide reliable values. As you can see at the table below, even if the GPS provides results in a very fast way, so about 30 milliseconds, and the web service in about 120, the results provided by the web services are much more precise. And so I wanted to invest sometimes more, about 4 times more than a GPS retrieval, but to have more precise values.